In this video, we will classify polynomials by their degree and number of terms, and then simplify using addition and subtraction. First, let's talk about what a polynomial is. A polynomial is an expression that has many terms in it. That prefix, poly, means many, and nomial means terms. So the word literally means many terms. Now we need to talk about the degree of a polynomial. The degree of a polynomial is the highest exponent in the expression. So an example of a polynomial looks like this: 2x cubed plus 5x squared minus 4x plus 7. There are 4 terms in this polynomial. The degree is the highest exponent. So this is a third degree polynomial with 4 terms. But instead of having to write out this sentence every time for its classification, we can actually condense that down into some specific terms. In order to classify, we can use the degree and the number of terms. So for our last one, it was of degree 3, which we would call a cubic. And it had 4 terms, and that would be considered a polynomial. So our previous example would have been a cubic polynomial. I want you guys to use these 2 lists to classify these 6 polynomials. Next, we're going to talk about standard form. Standard form is when we write polynomials using alphabetical order for the terms and the highest exponent first. So right now we have these 3 terms, 3x, 1, and 2x squared. We want to be able to write this polynomial in standard form. So alphabetical order means we use the letters for the variables and put them in order. There's really only one type of variable in this polynomial, so we don't really have to worry about alphabetical order here. So we go to the highest exponent. The highest exponent here is a 2. And so this will be our first term, 2x squared. The next highest exponent is a 3x, which has an exponent of 1. So that's our next term. And then lastly, our constant term. I want you guys to finish out these last 5 examples, writing them in standard form. When we're adding and subtracting polynomials, it's just like combining like terms. In order for terms to be like terms, remember they have to have the same variable and the same exponent. So as we take a look at this first example, we have 18x, and we're adding a negative 8x. We have to find the same exponent on that term, and that's the one that's going to match with it. The negative 2x squared is going to match with the positive 3x squared. The 15 is going to match with the minus 10. Those are going to be our like terms. So that when we combine them, I get x squared plus 10x plus 5. Negative 2x squared plus 3x gives me a positive 1x squared. 18x minus 8x gives me that 10x. And 15 minus 10 gives me that positive 5. Next, we have 6x squared plus 7x minus, and then notice the parentheses around this. What this really means is that we are subtracting this entire expression from this first one, which means we're really distributing that negative or that minus sign. So let's rewrite these expressions first. 6x squared plus 7x is not going to change, but on this second expression we have to distribute the negative. So minus 10x minus 3x squared minus 2. Now we can take a look at those like terms. 6x squared minus 3x squared. That's going to give us a positive 3x squared. 7x minus 10x gives me a negative 3x. There's not a constant term in this first expression to combine with the negative 2, so we just bring it down. So the final expression is 3x squared minus 3x minus 2. The x squared and the x are not like terms. One has an exponent of 1, one has an exponent of 2. So we can't go any further than this.